Yes, indeed.
All right. Trapezoids. This is the only four-sided shape that we haven't talked about yet. Okay? So what we're going to do is we're going to start off, but I'm going to draw you the two most commonly drawn trapezoids. Okay? Now, please do not be under the impression that there are only two kinds of trapezoids in the world. There are a gazillion billion different ways to draw a trapezoid. I'm going to draw you the two most common trapezoids that you would see. So if you were like me and you go to, what I do on the weekends is I like to go to estate sales and garage sales, and I always buy old math books. You know? And if you bought a bunch of old math books or new math books, it wouldn't matter, and you turn to the section in the math book on trapezoids, there are two kinds of trapezoids you would keep seeing in those math books over and over again. And this is what they look like. There's one of them which we call the right angle trapezoid, which looks basically like this. And it could be rotated in any direction you wanted it to. Okay? Or the other most commonly drawn trapezoid is one which I like to refer to as the Mayan temple looking trapezoid. Okay? And if you don't know what a Mayan temple looks like, you weren't paying attention in that part of history class when they talked about South American history probably. But a Mayan temple was shaped like this. The Incas made temples like this as well. Okay? So it was almost like a pyramid, but the top was cut off right here. But these, you guys, both of these would fall under the classification of trapezoids. Alright? Ask me why. That is a great question. So a trapezoid, let's figure it out. So a trapezoid has how many sides? Four. But if you look at it, how many of the sides are parallel? Just two. So it has how many pairs of parallel sides? Just one. Okay? So a trapezoid is the only four-sided shape that we study that has only one pair of parallel sides. Okay? All the other shapes we've studied so far, not only was the top and the bottom parallel, but the left side was parallel to the right side as well. On these, a trapezoid is only one pair of parallel sides. So that brings up, so what is a trapezoid? It is a quadrilateral. This is the definition of what a trapezoid is. A quadrilateral with one pair of parallel sides. Okay, there we go. That's the definition of what a trapezoid is. A quadrilateral with one pair of parallel sides. So can a trapezoid ever be a square, for instance? No. Why not? Well, trapezoids have 90-degree angles. But a square has how many pairs of parallel sides? Two. A trapezoid has just one pair of parallel sides. So there's your definition. Okay? Some terminology that we have that you have to know because I will be mentioning it. The parallel sides in a trapezoid are called the bases. So the two sides that are parallel we refer to as the base and the base. Some teachers call one of them base 1 and the other one base 2. You can do that. I don't care which one. If you do that, I don't care which one you call base 1 and base 2. And then the two sides that are not parallel are known as the legs. Okay? So a trapezoid has two bases, always. They will be the parallel sides. And a trapezoid will always have two legs, and they will be the non-parallel sides. Okay, and then there's something you notice when you look at a trapezoid, either one that I've drawn here. If you compare the length of the bases to each other in either trapezoid, how do the lengths of the bases compare? Are they different or are they the same?
Different.
They are different. Okay? The bases will always be different lengths. So, one of the bases in a trapezoid will never equal the other base. Not in a trapezoid. The bases will not be equal. Okay? And then all four, one more bit of terminology here, all four of the angles are called the same name because all four angles run along a base. All the angles are referred to as base angles. Okay? So all of these angles, we refer to them as base angles. Of course, we have in this trapezoid right here, the Mayan temple-looking trapezoid, we have two top base angles and we have two bottom base angles. Okay, but all of them are referred to as base angles. So there's the terminology. You're going to hear me saying stuff about the bases, about the legs, and you guys just need to know. The bases are the two parallel sides. The legs are the non-parallel sides in a trapezoid. The bases will never be equal, and all four of the angles are referred to as base angles. Okay? All right, so we're going to learn four properties, four rules about a trapezoid. So there are four properties that you need to know. Okay, and what we're going to do is we're going to follow the same format of the notes that we've been doing with all of our four-sided shapes that we've been learning about. So we're going to draw a diagram of a trapezoid. We're going to discuss a particular property about a trapezoid. And then we're going to do an example where we go ahead and we apply the property of the particular property of a trapezoid. Okay? So this is what our notes will look like. We'll have 3 columns. We'll always draw a diagram, a picture. But we're going to mix it up today. Typically, we drew a diagram, I told you the property, then we did an example. Today we're going to do it a little bit different. We're going to draw the diagram, we're going to solve out an example, and then you guys are going to help me figure out the property that we used, okay? A little bit different today because today's Monday. Alright, so let's draw a diagram of a trapezoid. Which one do you want to draw first? Do you want to draw the right angle trapezoid first or the Mayan temple looking trapezoid first? The Mayan one?
Yeah.
Alright, so let's do the right angle one. So the first one we're going to do is let's draw the right angle trapezoid. Not because I don't like you, whoever said Mayan, but because the property that we're going to learn is a lot easier to learn with the right angle trapezoid than it is with the Mayan trapezoid. Okay? So draw that. Label the vertices. Watch this. This is going to be super creative. T R A P. T R A P. That's fresh. No cap. Okay. How many degrees is angle T? 90. Good. Mark it. How many degrees is angle P? 90. Mark it. Now, somebody say out loud, you're free to speak. Give me a semi-intelligent angle measurement that angle R might possibly be. Just go ahead, yell it out. What? You said 45? No, I said an intelligent measurement that could be. I do like 145 though.
120.
Okay, so let's go ahead and make angle R 145 degrees. You guys, the reason why I said it has to be somewhat intelligent, is it obvious to you guys that angle R is an obtuse angle?
Yeah.
So that means whatever measurement you said had to be more than 90.
Yeah.
Okay? 45 was pretty good, better than first period. First period said 1. So that's a, wow. Okay, here's what I want you guys to do. For 30 seconds on your own, see if anybody could find the measure of angle A without my help. Okay, so the example, find the measure of angle A. See if you can do it without my help. Okay. I lied. That was actually 43 seconds. Right there. You guys, how many people think they know what it is? Just show of hands. Should be at least half of you, at least a quarter of you should know what it is. All right. Alex, what do you say it is? 35, he's right. Okay. Angle A would be 35 degrees. All right. Now, how did he get it? If you're not sure how he got it, watch what he did. The first thing you would have had to do is you would have had to use the n minus 2 times 180 degree formula. Okay, that is the formula that you would use to find the sum of all the angles inside any shape, any polygon. And in this particular shape, what would n be? What number would I put in the place of n? 4. Because n stands for the number of sides of the shape. So you would go 4 minus 2, which is 2. You would multiply that by 180, so that is 360 degrees. Okay, now that's not your answer. The answer is 35, but what that 360 means, it means that the measure of angle A plus the 90 plus the other 90 plus the 145, if you added all those up, they would have to equal 360. That's what that 360 means. Okay? And then what Alex did was, and what the rest of you did was, you guys solved this out, and you got the measure of angle A to be 35 degrees. Okay? But that would be the math, the actual math that you had to do to find it. Okay? Now, show of hands, how many of you guys have figured out that every time you have a four-sided shape, no matter what the four-sided shape looks like, the four angles always add to 360? Good. So you really don't even need this formula for a four-sided shape, because this formula will always spit out 360 for a four-sided shape. Yeah. Okay, so that's 350. All right. So now let's learn the property. Okay. Look at angle T. Look at the angle right below it. Add those two angles up. What do these two angles add up to? 180. Look at angle R and the angle right below it. How much is 145 and 35? 180. So if you notice, the base angle on the top and the base angle on the bottom that's consecutive with it, they add up to 180. What's that big fancy word that means two things add up to 180? Supplementary, and that's our property, and we're going to write it down this way. The consecutive top and bottom base angles are supplementary. Okay, so there's the property. So that means in this particular diagram, if you took angle T and you added it to angle P, those two angles would be equal to 180 degrees. And the same if you took angle R and you added it to angle A, those angles would also be equal to 180 degrees. Okay, and you guys can be relatively confident that this is true, that I didn't just manipulate the numbers, and it's because I didn't even come up with that number 145, you guys did. So it was like a random number that you guys picked, and yet they still added up to 180. Okay, so that would be the first rule that we have. Okay, the first property that we learned. There's going to be 4 properties. Okay, the next property, let's go ahead and use the Mayan temple trapezoid looking thing. Alright, so go ahead and draw a Mayan temple looking trapezoid. Like this. Should we call it TRAP again? Or do you guys want to call it ZOID? For Zoid. Okay, no response. I'll choose. Let's call it ZOID. Okay. So, just to make sure you guys are on the same page as me somewhat, like I'm on page 57 in the book, want to make sure you guys are around page 57 in the book, so to speak. What 2 letters would make up a base? Z and O. What's another base? D and I. What 2 letters would make up a leg? D and Z. Right, Z and D or O and I. Okay? And if you notice, O to I is a little bit shorter than Z to D. So the legs actually aren't equal to each other, but here's what I want you to do. I want you to go right in the middle, put a point right in the middle between D and Z. So that's called a midpoint, and put the congruent marks to show that that point is a midpoint. Let's call it M for midpoint. And then do the same thing, put a point as a midpoint between I and O, and put the congruent marks to show that it's right in the middle. And let's call that point R, because it's right in the middle. And then connect M to R. Okay? M to R has a name. Anybody remember the name of a segment that connects 2 mid-segments? Oh, I gave you the answer. Wow, you guys are awesome. Anybody remember the name of a segment that connects 2 midpoints? A mid-segment. Good job. So we have a mid-segment. In this picture, in this diagram. Okay? That's what M to R is called, a mid-segment. Okay, so a mid-segment, MR. Now, would you guys say this is safe to say? M to R is right in the middle. Would you guys say that's pretty safe to say? Alright, so it's right in the middle. Somebody give me, I need a number. I need a value that D to I is going to be. How long do you want D to I to be? 14. Okay? So mark D to I is 14. And then I need a value for the other base, Z to O. 5, 12. Give me an even to 6. I like that. Let's go 6. And then mark the mid-segment as x. And we are going to find the value of x. Okay? X equals. X is right in the middle. MR, which is a mid-segment, is right in the middle. So what number is right in the middle between 6 and 14? What number is right in the middle between 6 and 14? 10. Think about it. If M to R has 10, is 10 right in the middle between 6 and 14? Yeah, because 10 would be 4 away from 6 and also 4 away from 14. So guess what x has to equal?
10.
Now, does anybody know how to you were right, it is 10. Does anybody know how to mathematically figure out what's right in the middle between two numbers? Melissa.
14 minus 6 and then you divide that number by 2.
You were so close. Problem is 14 minus 6 is 8, and 8 divided by 2 is 4.
And then you add that to like 6.
That was one way to do it. There's a much easier way to do it. Come on. Come on. Last year you guys did this when you did mean, median, and mode. Yes, you add the two numbers up and you divide by 2. Watch, you take the base. One of the bases 6. Add it to the other base, 14. Then you divide that by 2. 6 plus 14 is 20. 20 divided by 2 is 10. Jalen, you are a genius. So in this case, x would have to be equal to 10. Okay? So what's the property? A mid-segment, how do you find how long a mid-segment is? You add up the two what? Bases, and then divide by
2.
And we're going to write that out in words, but we're going to make it sound smart. A mid-segment is equal to the sum of the two bases divided by 2. By 2. Okay? That's the rule in words. That's how you find a mid-segment. So if I wanted to write this out, the mid-segment, that is MR. If I wanted to figure out how long MR is, I would take the top base, which would be ZO. I would add it to the other base, which is DI, and then I would divide that by 2. So I would take the sum of the two bases, that means I add the two bases together, and then I divide by 2. There is the property about mid-segments. Okay, so if you guys are ever dealing with a mid-segment problem in a trapezoid, you're going to use this property right here. Okay? 2 properties down. There were 4 total properties, so that means we have 2 to go. We're 59% done.
Nice.
I know. Pretty awesome, huh? We're actually only 50% done. Okay, so now let's go on to the next one. And the next 2 properties have to deal with the trapezoid, but it deals with a special kind of trapezoid, which we call an isosceles trapezoid. So the next 2 properties will only work specifically on what we call an isosceles trapezoid. And for those of you who have studied math, and all that would be all of you, whenever you see the word isosceles before the name of a shape, what is that word telling you? It's telling you the shape has how many equal sides?
0.
2. Isosceles means that shape will have 2 equal sides. Okay, so when I say we have an isosceles trapezoid, which two sides, let's go back up here to this picture, which two sides would have to be equal? The legs, good. I said over here the bases can never be equal to each other. So that means the legs are going to be equal to each other. Okay? So this means that isosceles trapezoid means you will have two equal legs. And an isosceles trapezoid looks like a brick of gold. If you know what that looks like. Okay? If you don't know what a brick of gold looks like, come by my house. I have lots of bricks of gold. I'm a teacher. We're super wealthy. What do you think they pay us in? Yeah, gold.
Coins.
They just give us bricks of gold. That's how much money we make. I have so many of them, I just use them for like door stops. You know? And stuff like that. I have a bunch piled up and I'm growing plants in between them. So this is like a brick of gold right here. Alright? The two legs will be equal. You will know a trapezoid is isosceles if you have the congruent marks written or marked in that they're equal. Okay, you might not have the actual tick marks, you might have numbers there, but if it's an isosceles trapezoid, they'll be the same. Alright? Okay, just to show you that I'm not manipulating this problem, that you guys are doing it. Somebody give me a non-even number that would make intellectual sense for the measure of this bottom left base angle. 45. What? 33. 28.
45.
27. 41. Let's go ahead and make it 41 degrees. So mark that bottom left base angle is 41 degrees. And then what we're going to do is we are going to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. And then from those measurements, we're going to come up with a property about the angles that apply to an isosceles trapezoid that don't apply to a non-isosceles trapezoid. Okay? So, all of you, based upon the very first property that we wrote, where I said that consecutive top and bottom base angles are supplementary, you should be able to use this property, and you should know how many degrees angle 1 is. 139. Angle 1 would be 139. How could you mathematically figure that out? They're supplementary, so what would I do with the 41? Minus it from 180. So the way that you would find angle 1 is all you had to do was go 180 minus 41, and that's 139. That's where the 139 came from. Okay? So that wasn't a new property. We used the very first one, the very first property that we talked about in class. All right, but now let's learn the new property here. What do you guys notice about the left side of this trapezoid when I compare it to the right side? They're the same. Therefore, without doing any work whatsoever, how much is angle 2? 139. Okay, angle 2 would have to be 139 because the left side and the right side are the same because the legs are the same. For those of you who thought that, you are feeling the force. And how much would angle 3 be? 41. For the same reason. Okay, angle 3 would be 41 as well. Okay, and this brings us to the property. So what can we say about the two top base angles? They're both equal. How about the two bottom base angles? They're both equal. So the two top base angles are congruent, and the two bottom base angles are congruent. Okay? Base angles are congruent. That's a property. But here's the key to that property. As you guys are writing, I'll still talk, and I'll highlight it in yellow. That property that we just wrote, the two top base angles are congruent and the two bottom base angles are congruent. It only works specifically for what kind of trapezoid? An isosceles trapezoid. That's why I highlighted it in yellow, to show you that that property in yellow only works for that shape, which I highlighted in yellow. Okay, so if it's not an isosceles trapezoid, you can't use that property. This property only works on an isosceles trapezoid. Okay, and we got one more property that works for an isosceles trapezoid. And we're just going to write this one down. We're not going to do any work on it. We're just going to write it down and go, oh, cool. Okay? So once again, we're going to write this last one down, and then what are we going to do when we're done writing it down? Oh, cool. The diagonals are congruent. Wow, you're a fast writer. Oh, cool. The diagonals are congruent. They're the same. Okay? But once again, that property only works specifically for one of those.